So here in this problem, we need to resolve the given rational fraction into partial fraction. So let us begin. Now first, before beginning, we'll need to factorize the denominator. That means we'll need to find out the factors of the denominator. Here we have x raised to the power of 4 minus 16. Now this can be also expressed as x squared whole squared. That's the first term. And the second term will be simply 4 squared. The reason why we are writing in this fashion, because now we have is the difference of two squares. Difference of two squares means if we have a squared minus b squared, so this factorizes as the product a minus b times a plus b. Now in a case, a is equivalent to x squared and b is equivalent to 4. So if we substitute this, then we are going to get x squared minus 4 multiplied to x squared plus 4. Furthermore, we can again factorize x squared minus 4. So that's going to give us x minus 2 times x plus 2 multiplied to x squared plus 4. So that means x raised to the power of 4 minus 16 has got 3 factors. Now we can rewrite our given original rational fraction 8x cubed plus 46x squared minus 24x plus 120. That's the numerator divided by, so here we have x raised to the power of 4 minus 16, but we can write in terms of its factors as x minus 2 times x plus 2 multiplied to x squared plus 4. Because we have 3 factors in the denominator, so what we'll do, we will suppose that these particular rational fraction can be broken down into 3 partial fractions. The first one will be a over x minus 2. Then we have the second partial fraction, which is b over x plus 2. Then we have the next partial fraction where the denominator is x squared plus 4. Since it's a quadratic factor, so we'll have to express the numerator in terms of cx plus d. So we're going to label this as number 4. Our goal will be to determine the value of a, b, c, and d. So let us begin. So what we'll do, this is going to involve some algebra. All we have to do is we'll begin with equation number 4, and then we're going to multiply throughout with the denominator. So the denominator of the left hand side, which is nothing but x raised to the power of 4 minus 16, such that we get 8x cubed plus 46x squared minus 24x plus 120 on the left hand side. Whereas on the right hand side, we have x plus 2 multiplied to x squared plus 4 times a. Then the second partial fraction is going to reduce to x minus 2 multiplied to x squared plus 4 times b. And then the third partial fraction is going to reduce to x squared minus 4 multiplied to cx plus d. Now what we'll do, we'll expand and combine all the like terms on the right hand side, and that's going to give us the highest power of x will be x cubed. So its coefficient is going to be a plus b plus c, followed by x squared. So its coefficient is going to be 2a minus 2b plus d. Then we have x, whose coefficient is going to be 4a plus 4b minus 4c. And then we have the constant term, which is going to be, and then we'll have the constant term, which is going to be 8a minus 8b minus 4d. So here we clearly see that there are 4 terms. The first one is the term containing x cubed, second term contains x squared, third term contains x, and the fourth term is the constant term. Similarly, on the left hand side also we have 4 terms. The first term is 8x cubed, then we have 46x squared, followed by negative 24x and 120. Now what we can do, we can compare and equate both sides. So this is going to give us few equations. So we'll get a plus b plus c, that's the coefficient of x cubed on the right hand side, and this is going to be equals to coefficient of x cubed on the left hand side, which is simply 8. So this is going to be one equation. Let's call it equation number 2. Here I made a mistake, so this is not 4, this is actually equation number 1. Fine. Then we will compare the coefficient of x squared from both sides, so that leaves us with another equation 2a minus 2b plus d, so this will be equals to 46. So let this be equation number 3. Then we compare and equate the coefficient of x on both sides. So we have 4a plus 4b minus 4c, so that will be equals to negative 24. Fine. Let this be equation number 4. And then we have the constant term 8a minus 8b minus 4d. So this will be equals to 120. So let this be equation number 5. So what we have are 4 unknowns and 4 equation. So we can solve them to obtain the value of a, b, c, and d. This I'll be leaving as an exercise for you to try. It's a very simple exercise. I'll state the values here. So a comes out to be positive 10. Then we have the value b. B comes out to be negative 9. C has a value positive 7 and D has a value positive 8. Now we have successfully obtained the value of A, B, C, and D, which we will substitute back in equation number 1. And this is going to give us the required partial fraction. So we now have a over x minus 2. This is the first partial fraction. We'll replace a with 10 over x minus 2. Followed by negative 9 over x plus 2. And the third partial fraction will be cx plus d. So we have 7x plus 8 divided by x squared plus 4. So this is how we have resolved the original rational fraction, which is 8x cubed plus 46x squared minus 24x plus 120 whole divided by, in the denominator we had x raised to the power of 4 minus 16. So this was the original rational fraction, and therefore we have successfully resolved it into 3 partial fractions.